Hi, third graders. It's Miss Sanamio. I'm so glad that you guys are coming back. Some of you are doing a wonderful job of making sure you come and check your DMA. I had 3 people by 5 o'clock had finished their discussions. Hopefully today it'll be more than just 3. So let's keep up those skills, getting you ready for 4th grade, guys. All right, let's look at week 26, day 2. We have an addition problem. We are looking for the sum. Everybody remember that that's what we call the answer to an addition sentence. It's called the sum. We're going to take 734 and 249 and we're going to add them together to make a total. So this is a part and this is a part. And when we put those parts together, we make a total or sum, right? The whole. What is the whole when we put these two together? All right, so let's take a look at our problem. 734 plus 249. Remember, we can use what we know about taking 1 from this 734 and adding it to 249. And since we're putting these together, it doesn't matter what the order is that we put them together, it's going to be the same when we put it all back in one total sum. So I could do 734 plus 200, So take 1 away from 734, make it 733, and add it to this 249 and make it 250. This is going to make it easier for us to add these amounts together. So 700 and 200 is 900. 30 plus 50 is 80. And 3 plus 0 is 3. Now I take my hundreds, my tens, and my ones, and I put it back together, and I have 783. Okay, now let's take a look at 900, let's use the algorithm and do the same thing. Now, again, does not matter what order you put them into. You could take the 249 and place it on the top and the 743 on the bottom. With addition, order does not matter because you're putting the two amounts together and making a total. Now, with subtraction, it matters because you're taking a whole and finding the other part. So 9 plus 1 more would be 10, plus 3 would be 13. So I carry that 10 to the tens place. This is 40, this is 30, that makes 70, plus 1 more 10 makes 80. And 700 plus 200 is going to be 983. If I wanted to do it by place value, I could do 700 plus 200 is 900, which is right here. We have 30 plus 50, which is 80, which I have right here. And I have 9 plus 4, which is 13. 13, and that would give me Okay, so I see where I made my error. So instead of using my original numbers, okay, I made an error. So see, Miss Adamio realized that she made an error and had to go back and say, oh, wait a minute, where did I miss my thinking? So 700 plus 200 was 900. 30 plus 40 is 70. And now 9 plus 4 is going to be 13. So this 70 and 13 is going to make that 83, and then I have 983. So I kind of confused my thinking, but I had to look back over here and see where my thinking was whenever I was adding these ones from my algorithm here. Here I was using that strategy of adding one more to this 49 to make this 250. So let's go ahead and talk about what your discussion question for today is going to be. I want you to, with this addition sentence, I want you to round each one of those numbers to the nearest 10. We haven't done this in a little while, so I want to see how you guys do. Round each number to the nearest 10, then add to find the rounded sum or the estimated sum. So again, I'm going to repeat what I want you to do for discussion. I want you to round 734 to the nearest 10, round 249 to the nearest 10. Then I want you to take those two rounded estimates and I want you to add them together to see if they come out to close to the round or the sum that you have here, which is 943. Okay, that's what you're doing today for your discussion question. Okay, let's take a look at this word problem. Carter paid a total of $6 for 6 pairs of flip-flops. He paid the same amount for each pair. How many dollars did each pair of flip-flops cost? So we have our total and we have 6 pairs of flip-flops. So if he paid a total of $6 for all the flip-flops, we know that we're going to take the total, break it up into groups, which are the flip-flops, and we are going to get $1 for each pair of flip-flops. So if I were going to model this, which I can, okay, so if I were to take my $6 and break it up, here's a pair of flip-flops. That one's $1. Pair of flip-flops. Each one of those bars is going to be a pair of flip-flops. That one's $1. Here's a pair of flip-flops. That's $1. Here's a pair of flip-flops. That one's $1. And I need one more bar. And now I have 6 pairs of flip-flops. Each one of those pairs is going to be $1. So each pair of flip-flops costs $1 because, or since, right? Because $6 divided by 6 pairs is $1 each pair. Now I can check my division using multiplication, right? So my flip-flops are the groups, right? I have 6 pairs of flip-flops and each pair costs $1, so $1 each pair will give me a total of $6, which is right here when I do this 6 divided by, here's my total, here are the pairs of flip-flops, and this is the amount for each flip-flop. Okay, now let's take a look at that last problem. It's a fraction problem on a number line. It says label half. Remember, half is always going to be in the middle. This is broken up into 2 equal parts. This one whole is broken up into 2 equal parts. So if I were going to look at this based on a figure, here's my figure. Here is half. There's 1/2. Here's the whole. Here's another half. 2 halves is going to be right here. Also remember, we can use halves to make fourths, right? So we could do the fourths here. This would be 1/4, 2/4, 3/4, 4/4 would be 1 whole. But for right now, they're asking us to label 1/2 and 2/2. Okay, don't forget that discussion question on rounding each one of those parts or addends. We call them addends. So round each addend to the nearest 10. Add them together to see if your rounded amount comes close to the 983. See you later on in math. We're going to be working on fractions and whole numbers today. So see you soon.